Hi, Tom Walls, Carbide Processors. Router bit breakage is the topic. This is a good router bit. Okay, nice router bit, two-fluted spiral, beautiful little thing. These started out the same way. Now they are broken router bits. And let's see. Anyway, they're broken router bits. They both broke the same place. The customer sent back, I think they bought 8 or 10 or a dozen router bits or something. They sent them back. Those that aren't broken are burnt. They're discolored. And what I want to discuss is why this happens. About twice a year we hear from one of our customers with this problem. Quite often we hear from a lot of other people who aren't our customers about this problem. Router bits are designed to be run at a particular feed and particular speeds. Feeds and speeds are terms that are used a lot of different ways. Here, what we're going to use now is what I'm going to use is a speed is how fast the router bit turns. Okay? If you don't agree with that, just go along with it for the sake of this video. A feed is how fast it gets fed through the material. So speed is how fast it turns. Feed is how fast it gets fed through the material for the purposes of this video. As the speed, as it goes around through the material, the sharp pieces cut off material, which collects in the grooves or troughs or gullets or whatever you want to call it. You need to be spinning this fast enough that it's doing the cutting it's doing enough cutting as it moves through. If you move it too fast, you clog up the gullets and it's not cutting fast enough to clear a channel for you to push it through. If you don't spin it fast enough, you get a lot of heat buildup, and the heat buildup discolors it, particularly if you're using this in man-made material of any kind. Plastics, anything with a resin in it, anything that's glued, they can be very, very abrasive. You get a lot of heat buildup in it. So you need to move it. You need to spin it fast enough so at the feed rate, how much material it cuts, how much material it collects in the groove, match how fast it's feeding through. You can't spin it too fast, because if you spin it too fast, it cuts off more material than the grooves can handle. Okay? That's why it gets burnt. As to why they break at about the same place, you get into the question of whether tungsten carbide is flexible or not. If you're a metallurgist, metallurgical engineer, metals guy anyway, then you think tungsten carbide is pretty rigid. If you're a ceramics guy, then you think tungsten carbide is flexible because ceramics are absolutely rigid. If you're talking to a tungsten carbide guy, he's probably going to tell you that tungsten carbide is rigid because we don't want you to try and bend it. And the reason for that is by the time you bend it enough to see any difference or do you any good, it's going to snap. These bits typically snap about here, which is also the end of the burn mark. The reason they snap here is that you have flutes up to here, and then about here, about where they snap, it changes and you start getting into the no flute area. As you try and push it with a CNC machine, push it faster than it wants to go, you run into a lot of resistance. You start to get, one of two things happen. You actually start to get a little bend because tungsten carbide is, 6, 10, 12, 15, some percentage of cobalt, which makes it a little bendable. This part, which is essentially the same, bends. When it gets here, you have different characteristics, you have a different shape, and everybody knows that a curve will break where it's discontinuous, if you have a smooth curve, you're good. If you have a knot in the curve, if you have a weak spot, if you have a thin spot, that's where it's going to break on you. So it'll break there. The other reason it's most likely to break there is a lot of times people have got it buried to the top of the cutting in the material, and the material's holding it here, but the CNC machine wants to keep pushing it there, so that's why it breaks there. As to which factor is the greatest, you've pretty well got to look at the material and see what the break characteristics are like. But feeds and speeds are absolutely critical to machining life. We find a lot of people that aren't machining nearly as fast as they could because they just don't know. Anyway, they're absolutely critical. Make sure you're running the right feeds and speeds. If you don't know the right feeds and speeds, contact us. We may know them. We certainly know the engineers who design and build and manufacture these things, and they know them. So we will get you some answers. If it's not our tool, by golly, we'll be happy to sell you a tool that will work. So thank you very much. Have a good evening.